Lambda expressions were introduced in C++ 11 version, and before that function pointer was the only way to pass functionality as a parameter. The advantage that you get with lambda expressions is you do not have to create a separate function. Many times the functionalities that we pass as a parameter, they are small functionalities like compare function, right? And creating a separate function for this functionality and then passing a pointer to this function is cumbersome, right? Lambda expressions provide a quick way of doing it. You do not have to create a function. In fact, lambda expressions are also called anonymous functions. Without creating a function, you can pass the functionality or you can implement the functionality. So here we have the sort example. We pass ARR and ARR plus n, and if we do not pass the third parameter, then sort by default sorts in increasing order. Here was sorting by absolute values, and for that purpose we are providing a lambda expression for compare, right? A lambda expression is nothing but a function without any name, right? And for small works that you do not have to reuse, you can simply create an anonymous function, pass it then and there, right? Not have to write a separate function. So this is the syntax for lambda expression. This is capture list. I'll explain what is the content of this capture list. Then we have parameters. So parameters you can relate. They are like normal function parameters, right? We pass some parameters to this function. Then we have arrow and then we have return type. These two things are optional and we typically do not use them because lambda expressions are used for small functionalities. And for small functionalities, your compiler can guess return type most of the time, right? So we typically do not use this arrow and then return type. We write capture list, then parameters to the lambda expression, and then we write the body of the function. And you can notice that this is how I have implemented lambda expression here. So this capture list is empty. Then we have A and B parameters. Then in the curly brackets, I have written the body that I want to compare A and two elements of this array according to their absolute value. So whenever the sort function is going to do the comparison, it's going to invoke this lambda expression, right? We have passed the comparison functionality as a parameter here. Once we have called the sort function, and then if we print the array, we get the item sorted by absolute value. This lambda is used by the sort function to sort the elements, and we did not have to write a separate comparison function then pass the pointer to that comparison function. We provided the lambda expression here itself. Let's now quickly get an idea about the capture list also. What is this capture list? See, this lambda expression takes some parameters. Wherever it is called, the caller is just the sort function is going to pass two array elements, and then this lambda expression is going to decide how to compare these two elements, right? So this lambda expression, even if you have written in the main function body, it cannot access local variables of main. Say if I create a variable x here, int x, and if I define it with 1, and if I try to access x here inside this function, if I write cout x, this function, this lambda expression would give compiler error. Even if it is created inside the main scope, it cannot access the local variables of main. It's going to access only the parameters which are going to be passed by the sort comparison, right? Sort comparison is going to pass these parameters. This lambda expression is going to be executing for comparison and then going to decide which one is considered smaller or greater, but cannot access this local variable x inside this body. This is the body of this lambda expression, like normal function body. We have written it in curly brackets. We can write more lines inside it. For example, I can write cout hello or anything I want to write. But if I try to access x inside this body, right, this function body, I'll get compiler error. So if you want to pass these local variables of the enclosing environment of the lambda expression, you can use capture list for this purpose. I can pass x here, right, and this x will be passed by value inside this function. Now this body can access x. I can also pass x by reference by using $x, and now this function can modify the x also. Apart from x and $x, there are other syntaxes also in the capture list. We'll discuss those syntaxes in the upcoming examples. Here is one more modified example, and instead of simply passing the lambda expression as code here, we can create a variable also for lambda expressions. I have created a myCMP variable here, and I've just remove the code from here and put the code here. And these curly brackets in the next line, this is just for beautification of the code. You can write this in the same line also, that is also fine, right? So this is just a function variable, lambda function with lambda expression variable, and instead of writing this code here, I have first created a variable and then I have passed this lambda expression variable. Now when I call the sort function, the same thing happens and I get the items sorted by absolute values.